Hello, Math 2 students. I hope you're ready to combine three things that we already know in order to solve this quadratic equation. So we've been working on knowing what standard form is and identifying A, B, and C. We've been working on factoring, changing a problem that's in standard form into factored form, the product of two binomials on the problems that we've been doing. And we learned how to solve problems that are in factored form by using the zero product property. So today, we're going to take this quadratic equation and we're going to do all three of these things and we're going to find the solutions to that equation. So to begin with, standard form, ax squared plus bx plus c equals 0. The problem that we're doing right now is already in standard form. We have an A value that's an unwritten 1, a B value that's 15, a C value that is 36, and our problem is set equal to 0, so that is an equation in standard form. So our next step is we're going to factor to change that equation into factored form. So I have t squared plus 15t plus 36 equals 0. I know factored form is going to look like this. It's going to be the product of two binomials. So when I look at the signs, my C value is positive and my B value is positive. And so I know that both of my binomials will have a plus sign right there. Now I'm going to do the reverse of FOIL. And my first term is the t squared. And I know to get that t squared, I'm going to use t times t. My last term is 36. And my outers and my inners need to come out to the middle term, which is 15t. Now, for 36, I'm going to have to figure out over here in the land of opportunity, what opportunities do I have to multiply and get 36? Well, it could be 1 times 36. It could be 2 times 18. It could be 3 times 12, it could be 4 times 9, or it could be 6 times 6. All of those multiplication problems have a product of 36. So now to find out the one that we need to use, we need to find the one that multiplies to 36, but has a chance of adding to our middle term, which is positive 15. So if I add all these, this will be 37, this will be 20, this will be 15, this will be 13, this will be 12. If I subtract them all, this will be 35, this will be 16, this will be 9, this will be 5, and this will be 0. So I want the combination that can not only multiply to 36, but also add to 15. And when we look at all the possibilities, the only one that will work is if I use 3 and 12. So I'm going to put a 3 here and a 12 here. And so now if I check my outers, t times 12 is 12t. If I check my inners, that's 3t. And if I combine those like terms, 12t and 3t make 15t, which is my middle term. So it looks like I've just factored this thing correctly. So here's my equation in factored form. So that was the second step. Now I'm going to use the zero product property to solve this equation. Well, I don't have an x in front of the parentheses, or a t in this case. My t's do not have coefficients other than unwritten ones. So on this problem, I can find the solutions just by using the opposites. So I know that the opposite of positive 3 is negative 3, and the opposite of positive 12 is negative 12. And those are the numbers that will turn each set of parentheses into 0. So those are the solutions to this quadratic equation. Now, one thing that I'm going to do before I move on is I'm going to check both of those answers and make sure that they work. So I have t squared plus 15t plus 36 equals 0. Well, I want to know if it really does equal 0 when I put my negative 3 in. So negative 3 squared is 9. 15 times negative 3 is negative 45 plus 36. And I'm trying to find out, does that really equal 0? So 9 minus 45 is negative 36. And I'm trying to find out, does that equal 0? And as you can see, negative 36 and positive 36 does equal 0. So that is definitely one of my solutions. So I checked, and negative 3, if I plug it in for t, it definitely makes the left side come out to 0 to match the right side. What about my answer of negative 12? So I write down t squared plus 15t plus 36 equals 0. And my t value is negative 12. So 12 times 12 is 144. 15 times negative 12 is negative 180 plus 36. And I want to know, does this equal 0? And so 144 minus 180 is negative 36. And I want to know if that equals 0. And negative 36 plus 36 is 0. So yes, that checks out. And negative 12 is a solution to that equation. So here we go again. But this problem has one step that the last problem doesn't have. Our equation is m squared plus 10 equals 15m minus 34. And that is a quadratic equation because of the x squared, but it's not in standard form. Standard form, ax squared plus bx plus c equals 0. Ours does not equal 0. So the first thing we need to do before we can factor it or solve it is we need to put it in standard form. So I have m squared plus 10 equals 15m minus 34. And I'm going to subtract 15m from the right side of the equal sign and from the left side of the equal sign. So on the right side, this will become 0, and I'll only have negative 34 left. Over here, none of these are like terms. So I'm going to put it in order. So I have m squared, largest exponent, minus 15m plus 10. And then I need one more step. I need to get this negative 34 to turn into a 0. And if I do that, I have to add 34 to this side. So my problem becomes m squared minus 15m plus 44, 10 plus 34, equals 0. Negative 34 plus 34. Now there's my equation in standard form. My a is an unwritten 1, my b is a negative 15, and my c is a positive 44. So I'm going to set up my answer. In this case, we're still working with two binomials multiplied together. My c value is positive, so I know that my signs are going to be the same, and my b value is negative, so I know both of my signs are going to be negative. Now I've got reverse FOIL going on, and my first term is m squared, and the only way to get that is m times m. My last term is 44, and then my outers and my inners together need to add up to negative 15m. So now for 44, I got to go over to the land of opportunity and figure out how can I get 44? What opportunities do I have? 1 times 44, 2 times 22, 4 times 11, and I think that's it. So now I'm going to see all of those multiply to 44, but I need to find one that either adds or subtracts to 15. So if I add all these, I'll have 45, 24, 15. If I subtract them all, that's 43, that's 20, and that is 7. So it looks like the combination that I need that multiplies to 44, but adds up possibly to negative 15 is this one right here. So now I'm going to put my 4 here and my 11 here, and my outer is going to be negative 11m, and my inners are going to make negative 4m. And so negative 11m and negative 4m combine to make negative 15m, which is my middle term. So it looks like I have this thing factored correctly. So now I have to use the zero products property to find the solutions to this equation. And so it looks like there's no m in front of the parentheses. My coefficients in both cases are unwritten 1s, so I can just use the opposites. So my answers are m equals the opposite, which is positive 4, and m equals the opposite, which is positive 11, and those should be my two solutions. So I'm going to take my two solutions and I'm going to put them into my original equation and make sure that the left side does equal the right side. All right, so I'm going to take my original equation. So I have empty bracket squared plus 10 equals 15 times empty bracket minus 34. And I'm trying to check this. So I want to know if I put a 4 here and a 4 here, are those really going to be equal? So when I multiply that 16, and when I multiply that 60, and so on this side, 16 plus 10 is 26. And on this side, 60 minus 34 is 26. So these actually are equal. So that checks out, and I know that 4 is definitely an answer. Okay, so now I need to check and make sure that 11 also makes the left side equal to the right side. So I got that. 11 times 11 is 121 plus 10. And I want to know if that equals 15 times 11, which is 165 minus 34. And so 121 plus 10 is 131. And I want to know if 165 minus 34 is 131. So those are the same. So 11 does make the left side equal the right side. So that is the other solution to this quadratic equation.